Welcome everybody, you're watching Mr. Fugu Data Science. Today I will discuss pyramid flow. Feel free to reach out on socials. This is an interesting text to video as well as image to video open source model that can, given enough resources, run locally. This article and GitHub repo were updated today. This is brand new and I want to show you details, hurdles, and what we can expect. In the description and pinned comment below, I attached the GitHub repo as well as the Hugging Face. Here's the Hugging Face page. I'm going to leave this and the GitHub repo in the link in the description below, as well as the pinned comment. You have a demo section here that we'll get into. Here's a few of the videos that they rendered. This is a Tokyo scene. It looks pretty good. There's some issues with the legs and some ghosting as well as artifacts that you'll see if you pay attention to these videos. This is a very complicated scene with people moving in multiple directions and multiple people moving at once, as well as people in the background moving. It's pretty detailed. They did pretty good. The driving scene here, you'll notice that the cars just disappear as that little one comes up on it, which is kind of interesting. Something that's static, for instance, is wonderful. It's like almost cinematic, something you'll see in like a commercial. It looks great. You don't have a lot of moving parts here except for the flame and the smoke. I noticed a few things. You get to the end of clips, you can see something weird happening. And if you notice this one, you'll see it with the eyes, and then it starts becoming a little blurred. This happens in more than one clip. If you look at this, the tree starts to get a little blurred, and then the water looks a little bit different. And in general, it looks very good if you're not paying attention to these things. Looking at people is another thing, because that's really hard because you have little people and objects moving around, which can either distort or cause issues at the end of the clip as well. Going to the research article, they did provide you with the hyperparameters, which is great. For later, anyone trying to run this and do some fine tuning, you have a starting point. There's limitations that I wanted to mention. They mentioned that relatively short prompts due to the way that they train these data. And it also mentioned some issues with things happening over time with inconsistencies, which is apparent. When we do some evaluation on images, issue is they did comparisons against 𝗃 and RunwayML, and each of these looks good in the still frames. But what you should pay attention to is 𝗃 and Runway were trained on private data, whereas Pyramid Flow was not. They had publicly available datasets that they trained on. Now, if you're interested in what datasets they trained on, feel free, pause the video and look right here. But here's what they did for video and image training, and you'll notice this right here. So they're pretty transparent with what's going on. I hope that their benchmarking scores were correct and not manipulated in any way. I would like to be hopeful. If we go to the GitHub, I specifically want to mention some of the issues. Let's look at this. If we go back to the Hugging Face page, I'm going to show this for clarity. But this message is really important here, because if you're trying to downgrade into a lower resolution, even a 4090 GPU is not going to be able to do this, because you're going to need at least a minimum of 40 gigs from my understanding. And these were trained on 80 gig GPUs, which are the A100s. So let's go back. These are trained on A100 GPUs, right? On the demo that you have the availability of, this is also utilizing an A100 in the background. So you are not going to be able to run this on your own. Even though it's open source, you're still going to need a cloud resource. Replicate, from what I found, has a resource that you can use. But I don't know what the pricing is for this. It does not say the pricing. It's not going to be free. But here's one resource that someone put on Replicate. Here's what it is right here, if you're curious. The great thing is this is free and it looks pretty good currently. And it's a competitor to some of these closed source markets. That's a plus. Here's some of the benchmarking from vBench according to them. Hopefully these are accurate, but I don't know. They're saying that this could compare relatively towards Gen 3 Alpha RunwayML. But here's the benchmarking that they say. Here we go. I did 2 runs with this image. The results weren't that good. I could have improved the prompting, of course. I just wanted to see what it looked like. You could judge for yourself. Here we go. So this model is really interesting. The pyramidal flow is different than other algorithms. And since 99% of people are gone, let's get into it real quick at a simplified version. Look at this. You're creating a series of pyramid stages that work on compressed versions. Instead of working at each individual step, operating on a full resolution, instead what they're doing is they're saving computational costs by working at each step on lower resolutions and in the end ramping up. So it's a stage-wise ramp up of higher resolution as the process moves on. And because of this, you're able to to save a lot of tokens. It's like a 5 or 10x, I think. I'd have to go back in the paper to find it, but you could go on your own leisure to see this. And it says to improve efficiency more, the compression history is generated. So here's what's interesting. When they're going through basically frame by frame, the history of what happened prior is helping for the next frame. So it's like, think of caching. So you're taking information you've already seen and you don't have to reintroduce it again. And that's another step that's also saving your cost too, which is really useful. And what happened in the end, by using these two techniques, they were able to beat out some of these more demanding, resource-intensive algorithms. So they're getting a similar result, and then they're also doing it faster at a lower computational cost. Go through the paper, you'll see what I'm talking about. That'll be the conclusion of this video. If you thought it was useful, consider hitting that like button down below. It's free. If you'd like to see content similar to this or related to coding, feel free to hit that subscribe button. And if you subscribe, turn on that notification bell. I have a few ways that you could help support the channel if you're interested. Sorry, shameless plug, gotta do it. Buy me a coffee, Patreon, and channel memberships. That'll be it. See you in the next video. Bye.
Run free and dive into the sky. Hear the wind crying.